This is Eureka Math, and we are in Module 6, and this is Lesson 2. So we were working with number lines, and now we're going to start working with a coordinate plane, okay? And if you don't remember what a coordinate plane is, it means that not only are we going to be counting the numbers on a line, right? And here's our origin. And this could be 1, 2, 3, 4. Now, we're going to start going in both directions at the same time. 1, 2, 3, 4. And we're going to start plotting points, right? So, this is like the question we had on the last lesson about how is the pirate going to be able to find his treasure if he knows that it's 30 paces from the X, but we don't know what direction, right? So now we're going to start exploring both this X-axis and the Y-axis, okay? So horizontal line is X, vertical line is Y, and we're going to start planting coordinates. So this is 1 and this is 1, so our coordinates would be 1, 1, okay? Always X first and then the Y. So if I put a point right here, let's say, this would be 1, 2, and this would be 1, 2, 3, 4, okay? So first you count the X and then you count the Y. Okay, so coordinate system on a plane. And we're not going to start so complicated, we're going to start pretty light. So go to your Learn book, Lesson 2, name on your paper. And number 1, use a set square to draw a line perpendicular to the x-axis through points P, Q, and R. Okay, so if you don't have a set square, it looks like this. It's like a ruler, but it has 2 sides. Okay, so what we do is we line up this side to whatever line we're using, and that's going to give us a 90-degree angle always. Okay, that's where we're trying to make a perpendicular line. Perpendicular lines always have 90-degree angles. So, if they want us to make a perpendicular line from P through X, and they want us to make sure we have a 90-degree angle, okay, so we've got P, Q, and R, I would take my set square and I would line it up, okay, to make sure I have a perfect 90-degree angle. And then I would draw my line through, okay, and it's going to go like that. And there is my right angle, okay. So this line is perpendicular to the x-axis. Great, all right. Now, perpendicular means 90-degree angle, perpendicular means that it crosses. Let's see, so here's Q, and I'm going to turn my head a little bit. And Q is going to go through X at a perpendicular angle. So I would get my set square out. If you have your set square, your ruler that looks like an L, and line up the bottom line with the x-axis, and then line up with that Q. Okay, so there's your line. And here's your 90-degree angle. All right. And R. Well, let's see. R, they put that point right there for us. But we're still going to give it a little distance here. I'm going to line up my line at a 90-degree angle. Right there. And that is my perpendicular line. There's 90 degrees. Okay, so perpendicular means it crosses perfectly. X-axis is the one that they've given us, and what we've done here is we've really created a y-axis, but they're not calling it that yet. Okay. Enable new, oh, there they did, y-axis, yep. So if this is x, then this is y, x, y, x, y. Okay, so label those lines. Need to read the directions completely, don't I? Okay. Oh, that should be a B, shouldn't it? if this is A here, this should be B. Choose one of the sets of perpendicular lines above and create a coordinate plane. Mark 7 units on each axis and label them as whole numbers. Great. We're going to use this first one because it's up and down and it's just the easiest for us to see. We're going to create a coordinate plane on it. So I'm going to erase my little angle there. You know that it's a 90-degree angle. And now I'm going to write 7 units on each axis and label them as whole numbers. So 1, 2, 3, 4, 5, 6, 7. And then I'm going to go this way. 1, 2, 3, 4, 5, 6, 7. Okay? Now, if you have a ruler, that would be great. This is our origin. That's 0. Okay, right here, 0. And that makes this 1, 2, 3, 4, 5, 6, 7. We're using whole numbers today. Okay, whole numbers. And then 1, 2, 3, 4, 5, 6, 7. Okay. All right, so we've just created a coordinate plane going in 2 different directions. All right, number 2, use the coordinate plane, this one here that they've just given us. There's their 7. They've already given this, they've just copied the same one we just did. They went 0 to 7, 0 to 7. And here we've got our x-axis and our y-axis right there. Use the coordinate plane to answer the following questions. Okay, so name the shape at each location. Remember what I said? X coordinates always go first, then y coordinates. So we're going to count over 1, 2, so that's that line. And then the y coordinate is 5, so we're 1, 2, 3, 4, 5 right there. And I'm going to go up, and I'm going to go over, and that's my coordinate, 2, 5. And what's there? It's a triangle. Okay. Next one, 1 and 2. So I'll go 1 and 2. So 1, 2. And what's my shape? It's a circle. 5 and 6. Okay, there's 5. And there's 6. So I'll go up and I'll go over. And I landed right there on the square. You don't have to draw those lines in. I draw them in so you can see what I'm doing, but it's not necessary. It just helps me keep on track, right? If I draw that in, then I don't accidentally jump the line. I can see where I'm going, okay? And that one was 5, 6. And 6, 5. So here's 6. And there's 5, so that goes right here, and that is an octagon, isn't it? I can tell because it looks like a stop sign, and stop signs are octagons. Also, it has 8 sides. Which shape, does it have 8? 1, 2, 3, 4, yeah. 5. Which shape is 2 units from the y-axis? Okay, from the y-axis. So 2 units from would be x, right? That's our x-axis. From the y-axis. So anything on this line, anything on this 2 line. So what shape is on the 2? Well, the only shape there is a triangle. Okay. Which shape has an x-coordinate of 0? That would mean anything on this line, because this is our 0 line. And what is that? That looks to me like a parallelogram. Good thing we just got done studying shapes. Which shape is 4 units from the y-axis? So that would be 4 units from the y-axis and 3 units from the x-axis. Okay, so if it's 4 away from the y-axis, that means it's x4. And 3 units from the x-axis, that means it's y4, or y3. So I'm going to go 1, 2, 3, 4. 1, 2, 3. And I landed right there, and that looks to me like a rhombus or a square, but it's sideways, so let's just call it a rhombus, huh? Okay, good. All right, that's not too hard, is it? It's pretty easy. All right, let's try the next set. Use a coordinate plane to answer the following questions. The smiley face, okay, so now they've given us the shape, but we have to find the coordinates. So the smiley face, which is right here, smiley face, it is first the x-coordinate, which is right here, is 2. And the y-coordinate, which is right there, is 1. Okay? So we would write that like this if we were writing it out as coordinates. The diamond, looks like the diamond is right here. And that's also on the 2, but on the y, it is right here. So what is that? This is 3, this is 3.5, and this is 4. The line between 3.5 and 4 would be 3/4, right? So 3 and 3/4. And yes, we can use fractions on coordinate planes. Good. All right, where's the sun? The sun is right here. And that's on the 0. That's on the origin line for our x-axis, so that's 0. But on the y, it's in the same spot. That's also 3 3/4. Okay. And the heart, which is here, on the x-axis, that would be, so if this is 3, and that's 3.5, and that's 4, the line in between would be 3 3/4. Okay, and the y-coordinate, well, it's on the bottom line, so that's 0. Okay. Name the shape whose x-coordinate is half more than the value of the heart's x-coordinate. Okay, the shape whose x-coordinate, so x, is 1/2 more than the value of the heart's x-coordinate. So the heart x-coordinate we said was 3 3/4, and we want to go 1/2 more. Okay, so 3 3/4 plus 1/2, this would be 2/4, right, would be 3 5/4, which would equal 4 1/4, okay? So, wait a minute. So where's 4 1/4 on the grid here? There it is. We made a half jump, 1/4, 1/2, right? On the number line we jumped a half. So 4 1/4 there. And what shape is on that line? There it is. It's the star. Okay. Plot a triangle at 3 4. So remember, this is the x-axis and the y-axis. Do not get this mixed up. I've had students every single year who think that it doesn't matter. It's not y and x. It's always, always x and y. So let's find x and y, 3 and 4, and then let's plot a triangle. So here we go. Here's 3, right? 1, 2, 3. And the y-axis is 4. So that's here. So I'm going to go up until I get to that line, which is right here. And there's my coordinate. And I'm going to make a triangle there. Okay? Make a big fat triangle. Okay. Plot a square at 4 3/4 and 5. So 4 3/4 would be here. And 5 is here. That's the top line. Oh, that'll be easy to find. So 3 3/4 and 5 is there. And what am I making? I'm plotting a square. Okay. So make a nice square there. And plot an x at 1/2 and 3/4. So 1/2 is here, and 3/4 is right here. So that would make that spot there. And I could just put a big X marks the spot. Maybe I'll fill it in a little bit more so it looks more like a treasure map, right? They always say pirates make X marks the spot. Okay. Oh, look, the next question, talking about pirates again. Clearly, coordinate grids are super important for all pirates. The pirate treasure is buried at X on the map. How could a coordinate plane make describing its location easier? Well, do you remember the question in lesson 1 where the palm tree was our x-axis? And then if we go up like this, that would be our y-axis. And then if we said that it was 30 feet away, well, let's see. It wouldn't be 30 feet here, but 1, 2, 3, 4, 5. We could call that 1, 2, 3, 4, 5. And then this way we could go 1, 2, 3, 4, 5. Okay, and then our coordinate would be 5, 5. If we did this as, say, north and east, right, we could say that our coordinate was 5 paces north and 5 paces east of the palm tree, and they would go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Or they could go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? So, how could a coordinate plane make describing its location easier? It could explain how many paces means steps, to the x, and then now this for math purposes is an x coordinate and a y coordinate, but if we were using a map, right, and we put north on one side or east on the other side, or if we turned it upside down and this was north and that was south, and it doesn't matter as long as it's labeled, then we would know what direction to travel in and we could get out our compass. Okay, how many to the x? Using the coordinates. Excellent. All right. So that was nice that they tied in a little bit with our lesson from lesson 1. Okay, and your exit ticket, name the coordinate shapes below. Remember, x-axis is this way, y-axis is this way. Always the x first, then the y. Plot a square and plot a triangle. Okay, and just because it doesn't label 1/2 or 1 1/2 or 2 1/2 doesn't mean it's not there. Okay, just because it's not labeled doesn't mean it doesn't exist. So you might want to write those in and then plot those 2 shapes. Okay, then go back and do your homework and let me know if you have any questions. Great job.